Hello, everyone. My name is
Hello.
Jana Shea, and I am Chief Operating Officer of Energistics and your host and moderator for this webinar. Welcome. I'm joined today by Francis Morandini of Total and Alice Chanvin of Paradigm. Who are in lovely Pau, France, and by Laurent Denis of Paradigm, who is with me here in Houston. I would like to extend a warm welcome to all who are attending from many locations throughout the world. To get us started, we'll have a little bit of housekeeping. We want to ensure a pleasant listening experience for everyone, so for that reason, microphones have been muted for all attendees. We have a lot of ground to cover, so we'll take questions at the end of the presentation. We'll use the question panel, which you should see here for questions. So please submit them as you think of them throughout the presentation, and at the conclusion of the presentation, we will take them in order. Hopefully everybody can see on your panel how you can ask questions. And just as a reminder to everybody, today's presentation is being recorded and will be provided within 48 hours. You'll see a note about that. So to get us started, we want to set the stage and have 3 quick polling questions. Each survey question will pop up for a few moments. Please select your answer and submit. So I will launch the first one now. The first question is, are you familiar with RescueML, the open data transfer standard for reservoir and earth model? And your choices are yes or no. Okay. And of the audience on the call, we have 62% who are familiar with RescueML and 38% who are not. Next question, does your company use Rescue, which was the pre-RescueML data transfer standard? Okay. And of these, 39% do use Rescue, and 43% don't, and 19 don't know. Last question is, has your company implemented RescueML? And if the answer is yes, let us know which version. Okay, and as to be expected, not too many have yet begun using RescueML, but we hope that that will begin to change starting today with this orientation. And certainly afterwards, we're happy to work with anyone who is interested in working with RescueML. Okay, so that part's done. All right. let's go back to the presentation. Okay, so I'd like to start today by introducing our presenters. Francis Morandini is Earth Model Advisor for the Geoscience and Reservoir Integrated Platform for Total. Francis is a reservoir geologist who has specialized in design, use, and promotion of different development platforms and tools for research and in-house applications. For many years, Francis has been involved in building E&P standards with Energistics, which was formerly POSC, and Rescue, and he is a member of Energistics Rescue ML Special Interest Group and Executive Team. Elise Chambin is Product Manager at Paradigm. Elise has a geologist background with over 12 years experience at Paradigm, specializing in reservoir modeling for the G&G domain. For the past 2 years, Alice is focused on data management and data model integration for Paradigm Solutions. And with me here in Houston today is Laurent Denis. Laurent is Data Exchange Architect at Paradigm. He has over 12 years of experience developing and managing the development of software applications for the oil and gas industry with a focus on structural and reservoir grid modeling. Laurent is a member and leader of the Energistics Rescue ML Special Interest Group and Executive Team, and he also serves on the Energistics Architecture Team as well. So welcome to Laurent, Elise, and Francis. Our presentation today will include a little bit about Energistics, but we really want to spend the majority of our time talking about Rescue ML, and especially the demonstration of how Total and Paradigm are using this standard to enable business. So Energistics is a global nonprofit membership consortium that facilitates the development and adoption of technical open data exchange standards in the upstream oil and gas industry. And as you can see from the text here, our membership really spans the vast range of companies that work in the upstream oil and gas industry. That's the integrated operators, service companies, national oil companies, vendors, integrators, and regulatory agencies. The key messages I really want people to take away is that we're a member-funded, member-resourced standards development organization, and the standards we steward have been developed by and for the industry. What you will see today, and if you look at our other standards, these are not academic exercises. Development's driven by the industry requirements to address real-world business challenges. And we hope that that'll be evident when you learn more about these standards. So this is just a slide to give you an idea of the range of members that we have. It's not everybody, but it's the vast majority. And important for our purposes today are the companies that are involved with Rescue ML. And the companies that you see listed here have been instrumental in the development and deployment of the Rescue ML standard. And just to give you a broader view of what Energistics works in, we have a variety of, a whole family of standards. And our flagship standards include Rescue ML, which is for reservoir and earth models, WITS-ML for drilling, and PRODA-ML for production. As of this year, next generation versions of all three standards have been issued, and all are based on our common technical architecture, which means that the standard schemas may be used in any combination and with our Energistics transfer protocol to address a variety of integrated operations, use cases, and workflows. So today, of course, we'll be focusing on Rescue ML, but in the future, watch for more webinars to come on all of our standards and how they can be used and should be used in the real world. And finally, I just want to give you a little bit of context from a standards development perspective. So Energistics is one of a constellation of SDOs, or standards development organizations, serving the upstream oil and gas industry. Each has a different focus area, including Energistics, which of course focuses on data transfer standards. PIDEX focuses on supply chain data transfer, PPDM on data management, PODS for pipeline, Mimosa for facilities, and others. And there are others here as well. The standards organizations listed on this slide are part of the Standards Leadership Council, which was created to help identify synergies, address gaps, and minimize overlaps among the standards development organizations. So if you're interested in learning more about the Standards Leadership Council, be sure to let us know. So with that brief introduction, I'd like to turn the webinar now over to Elise Chambin and Francis Morandini. And I'm just going to change our presenter. Okay. And we're turning over now to Elise.
Okay. Thank you, Jana. In G&G context, operators working on the same field, performing data exchange across multiple applications or different specialists, sharing data for interpretation and modeling activities, are facing multiple challenges. So let's review them into more details. First, there is a gap in the data exchange process, and there is no possibility to exchange specific data types between multiple applications without data loss or inefficiencies, and most of the time embedded QC during exchange is not optimum. We can, for instance, consider incremental model updates and re-import the updated information instead of the whole set of data. Other examples are unstructured 3D grids used for flow or geomechanical simulations, and any project metadata, such as traceability. Let's say we want to preserve initial and updated dates, different versions of interpretation, and so on. Another challenge that are faced by specialists are that for other types, when sharing data, it's quite difficult to preserve the geologic information and relations between data. And this is lost when performing single trip or round tripping. Let's say, for instance, that we would like to capture the stratigraphic and structural frameworks or link between structural models and 3D gridded reservoir models. Finally, there is a real need to have an optimized format for archiving all interpretation and modeling data information, which does not require multiple files per data types and subtypes. RescueML business benefits are various, and data sharing formats, this new data sharing format offers the following possibilities. First, as an open format, it offers a complete flexibility for application selection criteria. The use case presented by Total today is a perfect example on how RescueML can be used as a centric standard format, enabling companies to choose their appropriate technical tools without being tied to data sharing limitations. As less focus is made on data sharing technical difficulties, RescueML facilitates integrated decision-making across multiple stakeholders, across disciplines, and across field partners during review. As RescueML format is optimized in a way that all data types and data relations are saved in one file, data sharing becomes much more efficient and preserves data integrity during transfer. Partial updates are possible. We'll see that during the presentation. Data sharing can focus on specific well or field interventions and is a key link in the reservoir model chain. Geologic knowledge and interpretation captured by specialists along the G&G cycle can be preserved during data sharing and are not lost. Data traceability is key in the new RescueML 2.0.1 format and allows capturing history on data. And it's a first step towards capturing all project uncertainties carried out through data exchange. Last but not least, this format allows extending workflows to unconventional resources. So let's now focus on the use case we will present today from Total. Sysmage CIG The Total for Geoscience and Reservoir platform implements a complete workflow for geology, geophysics, and reservoir studies. From Sysmage CIG, each Earth model item in depth or time domain can be exchanged or shared using RescueML formats. As an example, here are the different data types shared with Total application. So first, the type, we can start by well data, including VSP, seismic interpretation for horizons and faults, structural models with horizons and fault contact, stratigraphic model, surfacic or gridded, facies and petrophysical models, 3D reservoir grids, structured or unstructured, simulation inputs and results, including time-dependent properties, and so on. This implementation in Total is based on an open source API, FESAPI aka F2I Consulting. Here is a schematic view on how RescueML standards is used in Total. First, there is a strong link between internal development, Sysmage CIG, and RescueML. Then RescueML is used to transfer data with external applications to Sysmage CIG. Now it uses EPC files, what we're going to demonstrate today, and later on which evolves to Energistics Transfer Protocol. RescueML is also used as a reference for extending the current common data model for their in-house application development. And the use of RescueML embedded traceability functionalities is used for improved and secured data management. Here is the context used for the use case we're going to present today. RescueML formats will be used to share data between SCUA from Paradigm, Sysmage CIG from Total, and Petrel from Schlumberger. These data are not only representations, but a consistent set of geological or technical features and their interpretations, representations, or properties. This use case is a proof of concept based on real data. Similar data sets have been exchanged in several real studies. To set the stage, everything started with a 6 p.m. request from one of Total's team members. They said, we need those more than 1,000 wells and associated logs for tomorrow morning transferred from this application to the other. Make sure you include horizons and markers as well. We've heard that you wizards have magic trick to do that. What's your spell? To make a long story short, it took Total less than an hour. This is the story we want to share with you today. So let's switch to the demonstration. So here is the use case we will work with for data sharing. So modeling for this reservoir was initially performed in Paradigm SCUA modeling platform. For confidentiality reasons, we limit here data types to wells and structural information. The 3D reservoir geometry and petrophysical characteristics won't be presented. So here we can see that the project coordinate system is set to NAD 27, and units for data for this project were set up in meters. The reservoir has been delineated by multiple stratigraphic horizons, defining stratigraphic units and organized into a stratigraphic column. We can see here the different units of the model, and they're all defined as conformable. So let's review the different horizons in 3D. So here, for instance, we start by the topography of our field, and let's review the top of the reservoir and one intermediate horizon. Exactly 1,031 wells were drilled for this field, and each well contains tops and logs, and we will review this data into more details later on in the demonstration. So let's focus particularly on the west-east transect that we can see here. Each well has its own symbol, oil show, and we can see the different stratigraphic horizons displayed in a zoomed area. Around the well, so each well also has been displayed in a section view. So each well shows multiple tracks. So we can see that we have a stratigraphic track showing the different stratigraphic units defined along the wells. Then we also have facies information showing the different reservoir formation identified with the upper, middle, and lower formations. And each formation has been described into a lithologic table with different sand qualities: channel sands, laminated sands, shale, and so on. We can also see a saturation track showing effective saturation with effective porosity values. So we can clearly see that we have here a set of data that are interrelated with geologic information attached to data. So we see that for each stratigraphic horizon that we defined in our stratigraphic column, we have different data types attached to this stratigraphic horizon. We have our seismic interpretation, we have the different markers, and we can see the different list of well tops for each well. And this is this geologic information that has been captured by the geologist and that we would like to keep and preserve when performing data sharing with other applications. So if we check the total number of information that we have for this project, we can see that we have more than 1,000 wells, so 1,031 wells. We have more than 5,000 logs. We have more than 3,000 markers and different interpretation information. The entire set of data can be easily exported to RescueML 2.0.1 format through our export filter. So we just have to select the export filter, list the list of objects of data that we want to export. So here basically we're selecting everything. So the seismic interpretations, the wells. We can also define and select the well list, so the correlation that we created, and we just have to select the destination file. So this amount of data has been exported exactly in 47 seconds. The RescueML export result is composed of two data files, a .epc and .hdf5, and can be easily shared across applications. Going back to our use case, what we've performed so far, we've been using SCUA, we've exported a RescueML file, and we will now import this information in Petrel. The first import will be done in Petrel through a dedicated Petrel plugin developed by Paradigm, which allows using RescueML format for data sharing. Today we will focus on the file-based option, and we will select the RescueML file we just exported. The RescueML file is scanned in exactly 20 seconds. We can check that georeferencing information is preserved as the file is scanned, and we can review the project settings. We have similar project settings defined in Petrel and in SCUA. We can quickly select the different data type and inspect the RescueML file. So we can see all well data that have been selected. So here it's a combination of all well data, and we can see the source and the domain and the user and so on. So we highlight the wells, but we can also have a more in-depth information on the different well borehole that we have in the RescueML file, the different logs, and the marker sets per well, and so on. We can also check the well lists, and the horizons interpretation for both the gridded versions and the triangulated surfaces. So let's now import all of this data. The total import time for the entire set of data, so all the well data and the seismic interpretation, has been done in 2 minutes and 30 seconds. So let's import the data, and when it's done, we can check the status information here. So instead of new, as this information did not exist in the Petrel project, we can see now that it's similar, and we have an update on the status column. So let's review this information in 3D. So we'll start by viewing the same stratigraphic horizon, but the one we displayed in SCUA, with the depth information. And contours are preserved, and we can see that here we can show all the well data that we imported, and we can check that the well CMOL, so the well status, are preserved by default. Let's zoom in. We can quickly review the data in 3D. And we can see here that the different wells are listed here in the paradigm wells, and we also have the paradigm well list, so the west-est transect that we created with specific oil show symbols. So this information is also kept. So if we focus on the transect here, we can see them more closely. So not only the well data, the trajectory, the symbols are loaded, but we can also see that the well tops are imported, and they are color-coded by their horizon information, meaning that we preserved the link between the horizon, the stratigraphic horizon information, and the marker geometry information. So let's focus more closely on well trajectories. On the left-hand side, you can see a well trajectory in Petrel, and on the right-hand side, a well trajectory in SCUA. And we can see that we preserve the wellhead coordinates, the well datum, TVDA assessed at first import, and so on. So well trajectories are properly preserved, and we have a proper georeferencing information that is kept. As for logs, log types are properly preserved. We can see that logs are properly typed. So effective porosities and total porosities are properly tagged as porosities. Then we have saturation, which is preserved, and we also have facies logs. What we display here are facies logs on both applications, and we will see that in the template list, the lithologic classification, so the rock classification, is also preserved along the way while we perform data sharing. So not only we preserve the facies values, but also the classification and description attached to it. So you can see similar display between both applications. So now let's focus on another part of the workflow. So after having generated this RescueML file, what we can do now is to import it in Sysmage CIG. So Sysmage has implemented its own RescueML import plugin, and this data will be imported using RescueML format. So first, data is scanned in 1 minute and 30 seconds. So we just select the RescueML EPC file, data is scanned, so we can see the list of data here in Sysmage. And then data is loaded and imported in 4 minutes. Note that there is a CRS warning here as missing EPSG code in Sysmage is noticed. Let's review now the data that has been imported in Sysmage. So first, the different stratigraphic horizons, and then the different wells and the well lists. And if we check more closely in the different data tabs in Sysmage, we can see that we have So 1,031 wells, all the logs imported, and we can check all the different information that has been imported in the application. The stratigraphic column information is preserved along the way. And we will review this information in 3D. So you can display the 1,000 wells in 3D along with Smith interpretation for one of the horizon of the reservoir model. So let's focus now on our west-east transect. The geologists, for the purpose of this demonstration, will focus particularly on a saturation log zone to be edited on one well. So we check this well, and what we would like to do is to edit the values in this particular area. So for that purpose, we're using SysMerge tools, and we're just removing the values between two particular measure depth values. So this is the new display in the correlation view. If we check the value of the well logs, you can see that between those two MD values, there is no saturation at all. So what we would like to do now is not to send the entire well information back to the other applications, but to export just the edited data to RescueML format. So we will send the well trajectory and the edited saturation log through the RescueML export functionalities of SysMatch. And this is what is done. So a RescueML file is being created with the updated values. So now what we're going to do, we will use this edited value and send it to Petrel. So before loading this updated well log, let's review it first in Petrel. So for that particular well, we displayed the effective saturation. So you can see this saturation here in our correlation, on the wells of our correlation. So if we review the statistics and the histogram, we can see the values here. You can see that here in this MD interval, we have saturation values. What we'll do now, we will go back to our paradigm importer UI, and we select the updated EPC file. So we select the file, and we check the new information coming in. As you can see, two new well information are listed in the table. First, the wellbore trajectory, which is seen as older because the trajectory of the well has not been changed. So you're just one that you have a log which is attached to the well trajectory, and only the log is updated compared to what had been loaded already in Petrel application. So what we're going to do, we're going to import just this updated saturation log. And if we go back to the display, we can see that the saturation log has been updated along the way. So not only we allow to have partial transfers, but one new feature of RescueML 2.0.1 is the possibility to preserve traceability. And this is what is highlighted here. So you have different dates attached to the saturation log. So you can see that you have dates in November when the well was created. I did perform an import of this file in December the 6th, but on his side, Francis made some updates and modified the initial RescueML file December the 4th. So the modification of the RescueML file has been properly captured also, and the different imports within Petrel are captured also. So this traceability is preserved along the way. So that's the end of the video, and I will go back to the presentation. So the key highlights of the videos are the following. We managed to preserve georeferencing information. As you could see, the different wells that have been transferred between the different applications with a from third-party vendors or in-house applications from Total have been preserved. Not only data have been transferred, but also geologic links between objects, like the stratigraphic column or the links between the markers and the stratigraphic horizons, the property types for saturation and porosity and units, but also rock classification tables for the different facies logs that we had on our correlation. Also, we've been able to track and check for data updates, even for partial transfer of log editions. And last but not least, notice the optimized performance. So, as for performance, here is what we captured from our tests. Keep in mind that information such as the stratigraphic column, the rock classification, the geologic information, the coordinate system, the well list, and so on are also transferred. And you can see that those information were imported in RescueML file or exported in RescueML file in record time. So, to conclude, through this use case, we could feature that RescueML allows a proper transfer of data and data relations, even in partial transfers. This clearly is support of integrated operations across multiple disciplines. It allows robust and reliable data sharing of models, so less QC is required during data transfer, knowing that QC is most of the time a manual operation with hazards. So the use of standards aims at drastically reducing these QC operations. Note also that RescueML provides API, validation process implemented, and so on to ease those QC. Data model reconciliation cross vendors for optimal data sharing enables heterogeneous computing environments with multiple vendors, technologies, and platforms, and enables integrated decision-making across multiple stakeholders. And finally, standardized data format is clearly saving engineering time. RescueML Open Standard format has been designed to be easily extended based on customer needs and upon use cases. So developers will not be stuck by a missing RescueML feature in their application, and we can also consider improving and enriching the RescueML format based on community's feedback. So it's stable and provides robust functionality and can support new capabilities as they are developed. So today, we focused on sharing well data and seismic interpretation. But RescueML allows much more and allows sharing data types such as data type from seismic interpretation to 3D flow simulation grids and results. And these could be shown in other webinars, or for additional information, you can consult Energistics website. As we could see today, RescueML format is used by vendors and oil and gas companies for optimum data sharing. So I'm now handing back to Jana for the Q&A session.
Okay, thank you so much, Alice. It was really inspiring to see how companies are realizing RescueML to solve real-world problems that you see every day. And as you said, this was only one use case, but there are so many others, including the ability to archive in a standard format, which for anybody who is working with reservoir and earth models today knows that you're relying upon certain versions of software, and if you want to go back and use something from years ago, it can become a real challenge to be able to view that data. And the intention of the industry is that with this standardized format, that problem largely goes away, and which preserves data for you over the long term. So that's another use case, and our intention is to hold further webinars in 2017 to illustrate other ways that the companies are realizing the value of RescueML. So as a reminder, we do want to take questions now. Let me go to the next slide. And you can ask your question using the control panel. The reason we want to do it this way is so that we can preserve the questions and answer them and provide those answers on an ongoing basis. So it's easier for us if people ask them via the control panel. I also, while you're thinking of any questions you may have, want to draw your attention to the fact that we've uploaded a handout of this presentation, not the video, but the presentation itself, which you can also see under handout on the control panel. So, any questions? I'm not seeing any questions. Ah, here we go. All right. Our first question is there a way to sync and archive between these applications without having to know what data is changed? And that question comes from Stuart Lowry. So, Laurent, do you want to take that question?
I mean, if by that you mean that you want to be able to automatically select, for example, all the data that are changed after a given type, or all the data that are present in one software and not in another, yes, it's possible. It's currently not the using file for that is probably not the best way, but here it's an example using the file transfer, but using the new Energystic Transfer Protocol, it's possible to query what basically on the other side. So query the content of another application. So based on that and based on data information, user information, you should be able indeed to query what you need to be transferred from one application to another.
And then do the transfer with ATP.
And then do the transfer, of course.
That was our CTO, Jay Hollingsworth, who is also here in the room with us as well. Next question, also from Stuart, is there plans for socket-based exchange without Metafile in the middle?
Yes, that's basically the same answer than the previous question. That's the Energystic Transfer Protocol, and this is currently in development, and we hope to release it soon.
Okay, thank you, Laurent. And our next question comes from Daniel Brown. Thanks for an excellent demonstration of RescueML's power in sharing information between different software packages. To assist in software development and from an archival perspective, are there any conformance or compliance toolkits provided by Energistics that might assist in understanding what is in a RescueML archive, and if an archive is valid, or if an application is outputting correct RescueML?
Yes, there is currently a tool that has been developed by IFP and that will be available to on the Energistics website pretty soon, so that people can query the validity of RescueML document or any, hopefully at some point, any type of EPC file. So an EPC file can contain RescueML, but can also contain all the standard, Energistics standard.
That's right. Energistics will be providing this tool to the community at large very soon. It was developed in partnership by IFP, Energy Novell, and GeoCirrus. We call it an Explorer validator tool, so you can validate a file, but you can also make changes in the tool as well, and that might be a subject for a future webinar. So we'll definitely plan to do that. So the next question is from Setupati Arumugam. Do you have any experience on real-time usage of RescueML?
Yes, so that's the same answer than the two previous questions. Yes, we have some experience, and we are currently developing ETP, Energystic Transfer Protocol tool based on RescueML that will allow this direct transfer between applications. Yes, it's on development, and we already have a good experience about it, and it works.
Great, thank you. Our next question is from Alan Smith. We have had GeoShare and OpenSpirit, which were sold as providing similar solutions. What makes RescueML so much better?
So yeah, this is Jay. I'll try to answer that. So there are several reasons why this would be better, I suppose. OpenSpirit and GeoShare they were tied to a particular transport technology underneath them. One of the nice things about RescueML is it's plain ASCII data. You don't have to be locked into Corba as a broker or a DLIS file, which is what you had to do for OpenSpirit and for GeoShare. Another thing about RescueML is that it's a more modern look at the same data types. So with RescueML, there's effectively no limit on the gridding styles, the way you distribute properties around in those grids, the types of properties that you can move. Another thing that's nice about RescueML is that as technology changes, if you need to do something immediately without waiting for a new version of RescueML, there's organized extensibility built into pretty much every aspect of RescueML. So it's possible for you to get a little bit ahead of the standard, if you like, to get some extra business value. So there really are quite a few differences between GeoShare, OpenSpirit, and RescueML.
Great, thanks, Jay. So our next question is from Pradeep Joshi. Can we share or exchange 2D map or 2D grid data using RescueML between E and P platforms?
The answer is yes, and it was part of the yeast demonstration. I mean, when we say we exchange the horizon information, this horizon information, one of the representation was 2D grids, yes.
Okay. Thank you, Laurent. Our next question is, could we have more details about the open source API you mentioned?
You actually mentioned it, open source API. She mentioned an open source API.
Yes, we can.
I think it was.
So it's a library that is called FazeAPI that is developed by F2I Consulting, and I think if you contact us, we will be happy to send you the information about this open source initiative.
Okay, and we have a follow-up question from Alan Smith, which is, if I have OpenSpirit now, why should I change to RescueML?
Okay, that's a fair question, but OpenSpirit is tied specifically, it's a code base, and it's tied specifically to apply functionality to certain specific commercial applications. RescueML isn't bound to that particular list of vendors which are commercially supported by the OpenSpirit company. But having said that, RescueML isn't a commercial piece of software that you can buy. So it isn't a commercial API that you can buy, whereas OpenSpirit is a commercial API that you can buy. But you'll find that the data types covered by RescueML are far broader than any of the data types that OpenSpirit supports.
And I think that's probably one of the real answers to the question is you make a change when you get benefits from something new that you're not getting from what you have today.
Right.
So
this presentation was, the scope of this presentation was around well interpretation, which is a domain covered by OpenSpirit, but the reservoir grading part and all that comes with it and the link with flow simulation and so on, I don't think is available as broadly in OpenSpirit that it is in RescueML.
Okay, thank you both. Next question, what is the storage requirements for this data? Can it leverage open source Hadoop platform? And that question's from Keaton Puri.
So really this has nothing whatsoever to do with Hadoop. You could, I suppose, export data using RescueML. If you export data using RescueML, it comes out in an HDF5 file, which is an open standard for data storage and transfer used in the scientific industry. There may be a loader, you wouldn't use Scoop or Flume, but someone may have written a loader that would take HDF data and load it into Hadoop. But I'm not really familiar with that this really has very little to do with Hadoop.
Okay. Thanks, Jay. Next question comes from Jamie Vargas. Is the latest version of RescueML able to handle 3D grids with K-extended layers, school of geological grids, for import and export? And if yes, do you know if any vendors have implemented this commercially to transfer data between applications?
The answer is yes. This 201 is able to handle this type of grid, yes.
And vendors besides?
To my knowledge, to my knowledge, we are the only one currently that have implemented it, but nothing prevents others to follow the same path.
Has Paradigm implemented it?
Yes.
Okay. So at least one company has implemented it commercially.
Okay. Next question is from Garrett Carroll. In the software that is integrating the RescueML standard, do all fields, data types, tables, etc. need to be mapped to a standard set defined by RescueML? If so, what if there is no suitable mapping? Do new ones need to be suggested and adopted, or can these just be defined on the fly?
So as Jay mentioned earlier, RescueML is pretty extensible. So the idea in RescueML is you will be able always to extend. And for example, if you have a property type that doesn't exist, you don't just add it. You just don't add a new one. You try to add a new one and tie it as much as possible to existing ones. So we have, for example, some hierarchy of objects that allow us to define new objects, but still kind of getting a hook on an existing hierarchy so that you can interact with it like already existing object.
But then we always hope if you find a need to extend something in RescueML that you let the community know so that that extension can be incorporated into the standard at a later release.
Okay. So our next question is from Naveen Sharma. He asks, can we deal the data from OpenWorks to RescueML and RescueML to Petrel?
If OpenWorks implement a RescueML export, yes. I mean, I don't think there's any type in OpenWorks that couldn't be transferred using RescueML.
Yeah. Okay. And a follow-up question from Naveen Sharma is, which database are you using for RescueML? Is it Oracle or something else?
I mean, RescueML is a transfer protocol, so you can use it with the database you want, because the purpose is typically to transfer from one database to another database, or like Jana mentioned earlier, use it as a long-term storage for archival, long-term archival.
Yeah, I mean, the RescueML file is really just XML data. So there's no database involved. It's just a movement of XML data. And the EPC container we talk about is a special kind of zip file that just encases that that XML data. So there's no database involved. And then we move our floating point data via this special file format called an HDF5 file, but there is no database.
Okay, thank you, Laurent and Jay. And our next question is from Haiyang Chu. Can RescueML handle concurrent operations, for example, two applications write to the same RescueML file at the same time?
The file format doesn't do anything to prevent that. I don't know whether the HDF5 API allows two people to write to the same HDF5 file at the same time.
Yeah, I think there is the HDF5, there is a special version for concurrent access, but I'm not sure there is a concurrent access in right. But here we have presented the case where you have only one HDF5, and but it's possible that one EPC document can refer several HDF5. So technically, the HDF5 is the one that contains the bulk data, and the EPC file is the one that contains the metadata. So it's possible to have one metadata file that is referencing several bulk data files. So if it's something you want to do, you could imagine that each application will write their own bulk data, and they all refer the different pieces.
Okay. Thanks, Laurent. And so we have one more question and then one more poll question. So hang in there, folks. We're just about done. The last question is really for Jay. Is there a plan to have OPC UA model for RescueML as we are doing for WITSML?
Probably not. So the point of the harmonization between OPC UA and ProdML and WITSML is for electrical equipment manufacturers who are the OPC Foundation members to be able to use our transfer protocols for moving real-time process control kind of information. We typically don't do process control from an Earth model. There's no reason you couldn't describe RescueML in an OPC information model, but speaking on behalf of the OPC Foundation, we wouldn't have any they wouldn't have any members that would take advantage of that. So I would say nothing would prevent that, but we would have no reason to do it.
Okay, thanks, Jay. So we have one final poll question for you, and that is, now that you've seen at least one way that companies are using RescueML, are you interested in using RescueML for data exchange? So I'm going to go ahead and launch that question now. Almost there. Okay, I'm going to close the poll and share the results, and this is very gratifying. 96% of those who responded said they are interested in using it. We'll see if with future webinars we might convert the final 4%. And there was a comment in response to the poll saying, not really for Exchange, but for archiving. A shame there is no other option on the poll. I know what you mean. I tried to do the other, but I didn't have a way for you to actually type in. So thanks so much for the clarification there. Okay, so that actually concludes the presentation. I want to thank everybody for your attention, and especially thank our presenters and my partners in crime here in Houston for answering the questions. There is a poll that will, a brief survey that we'll execute at the end of this. Please do take a few minutes. We want to improve our presentation for the future. And also you can always send us a note and let us know what else you'd like to learn about, and if you'd like to get involved with the work that Energistics is doing. Just as a reminder, we're by the industry for the industry, so we rely on all of you in the industry at large to make sure that what we're doing is what you need. So I want to wish everybody a happy holiday and a safe new year, and we'll see you again on a future webinar. Thank you.